Hi, welcome to a new session of Circuits and Networks. In today's class, we are going to see the design of band pass filter and band stop filter. This will treat as class 2. In class 1, we have dealt with low pass filter and high pass filter designs. So what was the low pass filter design? Actually, a low pass filter design which is composing of T network when you send a signal composing of high frequency and low frequency combination based upon the pass band and stop band section of low pass filter. The filter gives the uh, low pass output and it filters out the high frequency signal, whereas the high pass filter it will attenuate the low pass signals and it will allow the high pass signal. This what we have learned in our previous class. So in band pass, uh, what happens is the it attenuates all the frequencies below a lower cutoff frequency and above an upper cutoff frequency, and it passes a band of frequencies without attenuation, and it is a composed of low pass filter followed by the high pass filter. So if at all you look into the design, the basic requirement is that the a signal which is composed of high frequency and low frequency signals under a desired frequency, the pass by band pass filter is supposed to allow the required uh, signal from low pass to high pass, so that you can see in this output signal. So generally, disturb the signal. In this disturb signal, we are interested to take out the signals which is ranging under low cutoff frequency and high cutoff frequency. So that signal is taken as the output. So generally, it is designed with T section low pass filter and T section high pass filter. You can see in T section low pass filter you have L by 2, L by 2 and C parameter, and in high pass filter you have 2C, 2C and divided by L, that is T-shaped network. These two combinations will give us the band pass filter. You can see the combination of these two is taken over here, where you have the low pass filter design with L by 2 as L1 by 2, L1 by 2, and the T is shared by C2. Under high pass filter, you can see you have 2C, 2C, so that becomes 2C1, 2C1, and this L becomes L2. So this is the T section of band pass filter. So you have the input signal and we'll get the output signal. So what are the design parameters? L1, C1, L2 and C2 are given by L1 equal to K by pi FC2 minus FC1, that is the low cutoff frequency and upper cutoff frequency. Then you have C1 which is equal to FC2 minus FC1 by 4 pi K multiplied with FC1 and FC2. Similarly, you have the formula for L2 and C2. We'll design and we'll also get the actual derivations of all these parameters, that is L1, C1, L2 and C2 in the later section. First, we try to understand how we are going to design the actual circuit. So after taking the parameters of L1, C1, L2 and C2, and we can also design the pi section band pass filter, which is again the combination of low pass and high pass pi sections. You can see here we have obtained the uh, K-type band pass filter under pi section. The design parameters will be the same. So for the input signal and output signal under T section and pi section, the design parameters are L1, C1, L2, C2, and based upon these four parameters, if at all we wish to design a filter, we can design with a given example where we have 4 kilohertz as low frequency, 10 kilohertz as high cutoff frequency, and the characteristic impedance is given by 500. So you take the data as it is and take the parameters of the low pass filter T section and pi section. We know that L1, C1, L2, C2 are given by these formulas. Just will substitute the values of K, FC2 and FC1. So L1 is obtained to be 26.5 millihenries. Similarly, C1 is obtained to be 0.02 microfarads. Similarly, L2 and C2 are obtained to be the following parameters as 5.97 millihenries and 0.106 microfarads. So this is the design of T section band pass filter. So substituting the values of L1 by 2 as 13.25 on either sections, and C2 is here obtained to be 0.106 microfarads. Similarly, you have to take the value of C1 multiply with 2 and you're going to get 0.048 microfarads for 2C1 value, and for L2 you're going to get 5.97 millihenries. So this is the design of T-section bandpass filter. Now if at all I wish to design pi section bandpass filter with the same values, what I have to keep in my mind, I have to take the pi section of low pass filter and high pass filter design in parallel combination, and then I have to substitute the value according to the design. So L1 C1 values with C2 by 2 and C2 by 2 are given by 26.5 millihenries, 0.053 microfarads respectively, and the other parameters, that is C1, which is 0.024 microfarads multiplied with 2L2, that is 5.97 multiplied with 2 will give you the value as 11.94 millihenries. So this is a design of band pass filter. So what happens up with the band stop filter? Actually, a band stop filter attenuates a specified band of frequencies and allow all frequencies below and above this band. So generally, it is also realized by connecting a low pass filter in parallel with high pass filter. So the signals with their high and low frequencies are taken as input, and the output it is desired to be filtering out the signals from the band of cutoff frequency with low and high conditions. You're going to see the signal in this fashion. And what if we require to design the filter? So for that T-section band stop filter, we have the L1 by 2 in parallel with 2C1 and L1 by 2 with 2C1 in series combination, separated by L2 in series with C2. Whereas in pi section, you have L1 C1 in parallel, which is again bisected by 2L2 and C2 by 2 on the either sides. So this is the design of band stop filter. Now the design parameters, you take the values of L1, C1, L2 and C2, which are mentioned on this formula. We are going to derive about these formulas in the later section. So first we are concentrating on the design constraints. So for that, we are going to take the data which is given in the second question, that is FC1 is taken as 2 kilohertz and upper cutoff frequency is taken as 5 kilohertz with impedance of K equal to 600 ohms. So we have seen already the notation of the T section. So with L1 C1 L2 C2 formulas, we are going to substitute the values of L1 C2 L1 C1 and L2 C2, and thus after obtaining the values of L1 C1 L2 C2, which is shown over here, we are going to design the T section band stop filter with the values as shown over here. Similarly, you take the same parameters and you design the pi section of band stop filter, which is given by this diagram, and substituting the values, you're going to get the pi section of band stop filter. So in general, for a low pass filter, the main purpose is to send low frequency signal and stop the high frequency signal, whereas the high pass filter, it will pass the high frequency signal and stops the low frequency signal. What about the band pass? It will send the frequency band for the selection, and it will attenuate all the frequency outside this band. Quite opposite to the pass band, the stop band will be allowing the signals which are lying frequencies outside the band, and it rejects the selected frequencies within the band. So you can see the generalized representation of T section band pass filter and pi section band stop filter. You can tabulate in your notes about all the filters and take the formulas and comment in the chat box whether you are able to follow this session or not. In the later section, we will take all the filters design and the corresponding parameters, that is inductor and capacitor and the characteristic impedance, and we'll solve some more problems related to all the passive filters. So that's all for today's session. I hope you like this particular session. Please share among your friends. subscribe to this channel and press the bell icon for the future notifications. Thank you.